So, hello everyone. In this lesson, we are going to study atomic structure. So let's get started with learning objectives. So these are our learning objectives. As you see that in this session, in this part, we are going to study what is an atom. So we will study the structure of an atom, and we are going to also state the properties of subparticles of atoms. Subparticles means protons, electrons and neutrons. These are the particles which are available in the every atom. So we are going to identify each subparticle. So let's get started with the definition of atom. As you see that when we define atom, we say that atom is the smallest part of matter. Okay, it is the smallest part of matter. It means in a matter, the smallest particle is called atoms. So in our definition, an atom is a fundamental piece of matter that cannot be divided into any other pieces. So what does it mean? Okay, it cannot be divided into any other pieces. What does it mean? Here I have an example to demonstrate. Okay, so in this example, why atom is invisible and indivisible, we will try to understand. Okay, so suppose you have some pieces of charcoals, okay, and you are going to cut them into pieces, as many as pieces, okay, as many as pieces possible. You are going to divide into small pieces. Let's see. So initially you can say that you have big pieces of charcoals. Then when you start cutting into pieces, you can see that there are many pieces of charcoal. So when you continue to divide into pieces, you see that you have very small tiny particles, many tiny particles, but here the particles are still visible. I can see. If they can be seen, it means that I can continue to divide. So when I continue to divide, you can see that still I have very small tiny particles of charcoal. So still, if they are visible, visible, so what happened? It means that I can also continue. So finally we are going to reach a point, or we are going to obtain a particles that particle cannot no longer be or cannot be divided. Okay, so these last particles cannot be divided. So cannot be divided means it cannot be divided. So that particle is called atom. Okay, that particle is called what? Atoms. It means that atom is the last fundamental particle of matter. It cannot be divided and it cannot be also seen by our naked eyes because it is very small. Okay, so usually the student, they ask, sir, can we see an atom by using microscope? So the using microscope, traditional microscope does not, or microscope don't give us the proper answer. We can see the animal cells, the plant cells, okay, by using traditional microscope. But recently the scientists, they could manage, okay, they could manage to see the locations of an atoms. Now I am going to display a video. In that video we will see, okay, the locations of platinums. And even before that, as the time goes and the microscope, they become more and more powerful. Since they become more and more powerful, the scientists, finally they could manage to, okay, show us the locations of atoms. Now I am going to display and we can see together.
Have you ever seen an atom? Seeing as everything's made of them, you have. But have you ever seen one on its own? Over time, microscopes have become more and more powerful, allowing us to see deeper into the world of the ultra-small. Traditional light microscopes can be used to see things like these onion cells.
Yeah, you can see that these are plant cell. The cells of onion, you can see these are the plant cells. Okay, exactly. These are through traditional microscope we can see that much.
and the structures within them as they divide, pulling apart their chromosomes. But scientists have come up with a whole host of clever methods to observe far smaller things. Using beams of electrons instead of light, we can generate detailed images of chromosomes themselves. Recently, groups of scientists around the world.
You can see that these are the chromosomes, okay, with your naked eyes by using, okay, the microscope, the beams of microscope. The scientists, they could manage to see these chromosomes. Chromosomes are very, very small, and they are the part of DNA, you know, huh? But even the scientists, they could manage to go further away. Now we will see in the video.
Becoming able to see materials at the most fundamental scale, the atomic. One group from the University of California in Los Angeles have been getting up close and personal with nanoparticles of platinum, just a few nanometers across. Each of the tiny dots you can see here are actually individual platinum atoms.
Yeah, this is a small part of platinum element, okay, platinum metal, and each small dot, you can see there are 27 dots, okay, in this small part of platinum, and each of them is an atom of platinum. It's really incredible, amazing.
But researchers didn't stop at a two-dimensional picture. By imaging over 100 slices of the nanoparticle at different angles, then removing the noise with a special filter, they were able to map the location of almost every atom.
You can see that they could manage to identify the location of every atom in another particle. This is really amazing. It's really surprising. You can see each dot is an atom.
The information was used to create a three-dimensional reconstruction of the whole particle in unprecedented detail. It may look blurry, but this particle is estimated to contain over 27,000 atoms, and so, like flies in a swarm, they appear to merge together. Every so often, though, we see the platinum's atomic structure align, granting us a moment of clarity. This technique is being used to analyze tiny irregularities in the structure of the particle called dislocations. Dislocations are subtle, like the misalignment of the green and red layers of atoms in this particle. But nonetheless, they can significantly change the properties of materials, with effects ranging from a change in the efficiency of LEDs to the strength of metal alloys. Three-dimensional atomic scale imaging like this is bettering our understanding of the structure of materials on this truly fundamental scale.
Yeah, you can see that using three-dimensional imaging of these locations, by this way we are able to see. It's really incredible. So as we learned the definition of atom, we can see atom is the last particle of matter, okay. When we divide to cut anything, you can take like you can take like an apple, you can take like a piece of paper, you can take, okay, like a kind of stone. When you start dividing into pieces, the last piece which you cannot divide into any other pieces is called atom, okay. So let's discuss, since I said atom has three subparticles, okay. These subparticles are protons, neutrons and electrons. It means that an atom is made up by proton, neutrons and electrons. These are the main parts, and these parts are smaller than atoms, okay. These parts are smaller than atoms, and atom is made up by proton, neutrons and electrons. So we can say every atom consists of these three subparticles. So we are going to analyze. Before going to analyze, I would like to also tell you the location of these particles, okay, how they exist in an atom. Here you can see that in this shape, these are the locations, okay. So currently I can say in the center of every atom there is a dense area. This dense area is called nucleus, okay. This dense area is called what? Nucleus, okay. And protons and neutrons are available in this area, okay, the seat of an atom. Then the seat is, or the nucleus is surrounded by circles, okay, by circles. So in these circles are like 3 dimensions, okay? Just to make you understand, we draw simple circles, but normally they are 3 dimensionals, okay? Dimensional circles, we can say shapes or orbits, okay? So electrons are available inside these circles. They are moving, okay? They are in constant speed. They are moving, okay? They are moving in this circle. So these circles are called energy levels or orbits. Orbits or energy, okay, levels. As it is seen in these pictures, in the seat which we call nucleus, there is protons and neutrons, okay, and around this nucleus there are circles and electrons are available in these circles. These circles are called orbits or energy levels. Okay, so what we understand, we know that protons and neutrons are located in the center of atom, that is called nucleus. Electrons are, okay, available around this nucleus in the shells or in the orbits. Okay, after learning the location of the subparticles, we are going to state the properties of each particles. Okay, let's get started with protons. So protons, okay, you can see the protons are available in every nucleus of matter. The first, as it is seen in the first, they are available in every nucleus of matter, and they have positive charge, and they have 1 unit mass. They have 1 unit mass, and 1 unit mass means, you may ask what does it mean? It is atomic mass unit. So what we understand simply about protons, first of all, protons are having positive charges, okay, they have 1 atomic mass unit, okay, they are present in the nucleus. Rather than this, my dear, protons are very important, okay, because now I am going to show you, okay, this is the periodic table. In this periodic table, as you see that every atom has proton numbers 5, 6, 7, 8, 9, like I can come here 48, 51, like 68, and you can see 188. So in this periodic table you see that every element has an atomic number, a proton numbers, okay? So this proton numbers are unit for elements. What does it mean? Suppose Jason, okay, Jason has an ID card, okay, ID card. In ID card there is a number, okay, like A, 1, 2, 3, 4, 5, 6, okay, J. So this ID number, okay, is only related with Jason. In the whole world, okay, among that much people, only Jason has this ID number. Another person may not have same ID numbers, okay? It means that, like, for example, my passport number, okay, my passport number is unique, okay? In Turkey, among the 80 million people, only that my passport number, it only, I am the one only have that passport number, okay? Like, if I can say AUXW, so this is my passport number and it is unique. Like this, every single element in the periodic table has a unique proton number. For example, if I say aluminium, because the proton number is 13. In the periodic table, among all the elements, aluminium is the only one which has 13, okay, atomic number or proton number. That is very important. So what we can say, protons identify the elements as like our ID numbers, okay? So the function of proton is very important and significant. So what we know, a proton is, or proton number can help us to identify the elements. For example, if I say that lithium has 3 atomic number or 3 proton numbers, this 3 proton number, it only belongs to lithium. No any other element may have the proton number of 3, okay? So proton number is very important. It just helps us to identify the elements. Okay, in the second electrons, as you see, okay. So electrons are having negative charge. Electrons are having what? Negative charge. They are represented by small e. Let me write also. And electrons are having mass of 1/1840. It means that one electron is 1/1840 times smaller than, okay, proton. Or one proton is bigger than or heavier than 1,840 times from an electron, okay, like almost 200 times, 2000 times a proton is heavier than an electron. So they are very, very light. Electrons are very, very light as compared to protons and neutrons. So you can see the function of electrons we are going to study in chemical bonding in that chapter. They play a decisive role in determining the chemical properties of an element, especially those in the outermost shell of an atom. It means that atoms, they have shells. In the last shell, those electrons which are present in the last shell are called, okay, outermost shell electrons. So these are very important. They involve, okay, these electrons are involved in chemical bonding. That's why they are very important. Okay, our next particle is, neutrons. So neutrons, my dears, you can see they can be represented by small n, okay, and they don't have any charge. Neutrons, they don't have whether positive or negative charge, and they have mass, okay. So the mass of a neutron is almost same or equal to the mass of a proton. So we'll say protons and neutrons, they have almost one atomic mass unit, okay, and they are heavier than an electron almost 1,840 times, or you can say that like 2,000 times they are heavier than an electron. And neutrons, they have no charge, okay, they have no charge, so they are present in the nucleus. I forget to write, but we can also add, they are found, okay, in the nucleus, okay. And let me summarize so far what we have learned about the subparticles, the locations of atoms, okay. So in this table you can see we are having, okay, protons, neutrons and electrons, and we are going to check what type of charge they have, their locations, their mass and their functions or their jobs. So here, as we know that proton, it has one positive charge, while neutron has no charge, and electrons, they have negative charge, -1 charge. So their locations, protons are located in the center of atom, which we call the nucleus. Same, neutrons are located in the center of atom, in the seat of atom, which we call the nucleus. And of course, electrons are present in the shells around the nucleus like this. These are the electrons and protons and neutrons in the nucleus, okay. These are shells or energy levels, as I mentioned. So for the atomic mass, as we study, as we seen in our previous slides, the mass of neutrons and protons are almost equal. They have one atomic mass unit, okay, and they are almost smaller than 2,000 times, they are heavier than the mass of an electron, okay. And their functions, as we study, the function of protons, they determine or identify elements, okay. So that is very important. As I told you, the proton number of an element is unique, okay, that's why it identifies that element. And for the function or the job of neutrons, we can see it supplies proper mass to the whole nucleus together. It means that since electrons are very, very light as compared to the mass of proton and neutron, so we can say the main mass or the majority mass of an atom can be supplied by protons and neutrons. And the function of electrons, you can see electrons, they determines bonding, okay, or they are involved in chemical bonding, okay. It's very important. So these are the end of our the video, our part 1. In our next video we shall meet again. Thank you very much for watching.